Good morning, good afternoon, good evening. Let's finish up chapter 2. Let's finish up chemistry. We're talking about the pH scale. We said that pH, we didn't say this. Let me say it now. pH is actually a mathematical formula. pH. Yes, it is supposed to be little p and big H. P stands for log, as in logarithm, as in the log button on your calculator. H stands for the hydrogen ion concentration. In my beaker of solution, there are a certain number of water molecules, and there'll be a certain number of those water molecules that will spontaneously fall apart. pH measures the number of them that have fallen apart. pH measures the number of hydrogen ions in my solution. Hydrogen ions, anytime you put something like that in brackets, it means concentration. We know that the pH of 7 is neutral, and we said that in the last video. If I have a pH of 7, that means my hydrogen ion concentration is 1 times 10 to the negative 7, which means I have a 1 in 10 million concentration of hydrogen ions. It means I have 1 hydrogen ion per 10 million water molecules. Let's look at pH of 4. If I have a pH of 4, it means that my hydrogen ion concentration is 1 times 10 to the negative 4. Notice the pattern? If it's 1 times 10 to the negative 4, that's, remember it's negative, so I start with a decimal point, and I go back how many places? I go back 4 places. 1, 2, 3, 4. Tens, hundreds, thousands, 10,000s. That means my concentration in pH 4 is 1 in 10,000. That means in this beaker, I had to pull out 10 million water molecules before I found 1 hydrogen ion. And remember, hydrogen ions are the essence of acidity. If something is acidic, it's because it has a lot of hydrogen ions in it. If it isn't acidic, it means it doesn't have a lot of hydrogen ions in it. In my pH 4 beaker, how many water molecules do I have to pull out before I find 1 hydrogen ion? 10,000. Which lottery would you rather buy a ticket for? Where you have a 1 in 10,000 chance of winning? Or a 1 in 10 million chance of winning? Oh, I'd rather buy one in the 1 in 10,000. No, don't. Put your money in your pocket. 1 in 10,000 chance of winning. That's 9,999 chances of losing. pH measures the acidity of a solution. pH 7 is neutral. The further away you go from 7, the worse it is. And the pH scale runs from 0 to 14. So if it's below 7, it's an acid. If it's above 7, it's a base. Now, pH 1 obviously would be really acidic and would burn you, right? You wouldn't want to touch that. Well, then what about pH 13? If a base is the opposite of an acid, well, then it's like fluffy and soft like puppies and kittens? No, a base of 13 is going to be just as nasty as an acid of 1. All right, we're just saying that it has a far lower hydrogen ion concentration, but what it has a very high concentration of is the hydroxide ion, that OH negative. So if I have an equal number of H pluses, hydrogen ions, and OH minuses, hydroxide ions, then I'm going to have a neutral pH. Acid means I have way more hydrogen ions than hydroxide ions. Base means I have way more hydroxide ions than I have hydrogen ions. Acids, bases, and salts. And we already talked about how a salt is an equal mixture of an acid and a base. Oh, one last thing about the pH. It was here, it wasn't exactly obvious here, but notice how our pH changed 3 places, right? From pH 7 to pH 4. pH changes by what's called an order of magnitude, which means each full step is 10 times worse than the last step. So pH 4 is 10 times as acidic as pH 5. And it is 100 times as acidic as pH 6. And 1,000 times as acidic as pH 7. The pH scale moves by orders of magnitude. Each full step is 10 times different than the last one. A buffer is something that resists changes in pH. So if I add a bunch of acid to a buffer, it's going to remove it, it'll neutralize it. If I add a bunch of base to a buffer, it will neutralize it. It tries to bring the pH back to normal. Whatever that buffer is, you can make a buffer that keeps stuff at 7 or at 6 or at 8 or at 10 or at 4. You can make a buffer to stay at whatever pH you want, but that's the point of the buffer, is to keep it at that pH, regardless of where I started at. If I add a bunch of acid, the buffer will neutralize it. If I add a bunch of base, the buffer will neutralize it. Buffers. They will pull extra hydrogen ions out of the solution if you add an acid. They will replace lost hydrogen ions if you add a base. Remember, adding bases means they suck up hydrogen ions. So if we start in the center, this is a neutral solution. And if you count, we notice there's an equal number of hydrogen ions as hydroxides. And what happens when I put H and OH together? What do I make? I make water. All right? So this is neutral. This is pH 7, an equal number of hydrogen ions as hydroxides. If something is an acid, it means it has a lot of extra hydrogen ions. So if you look over here, we see that there are more hydrogen ions than there are hydroxides. That's why this is an acid. A base is the opposite. A base is I have a lot more hydroxides than I have hydrogen ions. The hydrogen ion is the essence of acidity. If something is really acidic, it means it has a lot of hydrogen ions. If something isn't acidic, if it's basic, and we don't say basic, we say alkaline, like an alkaline battery. If something isn't acidic, if it is alkaline, it means it does not have many hydrogen ions in it. Water is what makes life possible on Earth. When scientists look and they search the galaxy, when they look at other planets to see if there's possibilities of life there, the first thing to look for is look for water. Is there water there? If there's water there, there's a chance there could be life. Please make sure that you send me any questions that you might have. Don't forget to sign up for Discord. You can send me questions through there. I'll be logged in to be able to take questions. Look at the syllabus to find out what times to look for me. I can answer questions in real time right then. Thanks a lot. Bye.